Easy now, bring it up slowly. Watch the cables, we have high tension on the starboard side.
Lower gently, set it down easy on the blocks, and secure the hydraulics. We have stabilization.
The induction heater gets the rust brittle, then we can hit it with the impact gun. Otherwise, it just shears off. We're looking at the depth gear assembly here. The corrosion is significant, but the spring mechanism is still intact.
The high-frequency cavitation lifts the corrosion right off. It's the only way to safely restore the brass components.
This 3000-watt fiber laser allows us to precisely remove the corrosion layer by layer without damaging the underlying structure. The laser scanner captures the precise geometry of the corroded detonator, allowing us to reverse engineer the missing components layer by layer. Once the resin mount is ready, we dip the component into the chemical bath. The reaction creates that deep black magnetite layer. We use a specialized aerosol mist to ensure even coverage before the final wipe down. The specialist applies a precise coat of matte navy black, essential for preserving the recovered shell before the curing process begins. The alignment is precise. We can begin torquing the bolts on the gasket now. These brass fittings are original to the 1944 design. Getting the threads clean enough for reinstallation is the hardest part.
Slings secured. Take the tension.
The corrosion here is extensive, especially around the seam. We'll start with the laser cleaner before moving to the brushes. The solvent is penetrating the micro cracks now. We need to tap it lightly to break the corrosion lock before we wipe the residue. We apply the induction coil directly to the stud. The rapid thermal expansion allows us to break the corrosion bond without damaging the housing. The corrosion here is significant. We use the impact wrench to break the seized threads before a full structural assessment. Bring the hoist slowly right. We need to check the backlash on that main reduction gear before moving it to the cradle. The corrosion is heavy, but it looks stable. The clockwork mechanism is the heart of the mine. Every gear must be meticulously inspected for corrosion before cleaning. We're running a 10-minute cycle now. The cavitation bubbles should strip away the marine growth and grease.
The 3000-watt fiber laser allows us to remove decades of corrosion without damaging the underlying structure. The laser allows us to capture the precise geometry of the damage without touching the delicate surface.
We have to rinse the resin thoroughly before the UV cure, otherwise the surface finish won't hold up underwater. The bluing process happens fast. We submerge the brass, and the oxidation creates this protective layer almost immediately. We apply the grease evenly to ensure a perfect seal before lowering the hemisphere. Any pinch here compromises the integrity.
The acoustic mechanism is fully functional. We've preserved this piece of naval history.
Lock pin engaged. Cables show green. Confirm secure. Bring it up.
The transport straps must be tensioned correctly to stabilize the corroded shell for the lift.
After decades underwater, every component is seized. The impact wrench provides the torque needed for extraction. The scanner gives us the precise measurements. Now, we print the replacement using high-strength resin to restore the aircraft. We apply the mineral oil while the steel is still hot, sealing the finish. After the initial cleaning, we apply the primer coat, followed by the matte black. These heat lamps ensure a perfect, durable cure across the surface. The assembly is seated. Now we tighten the retaining ring with the precision screwdriver and check the gear rotation.
This rubber seal is crucial. It has to be perfectly seated before we bring the top hemisphere down.
The spring mechanism is fully restored. We're getting consistent readings across the cycle.
Cleaner.
All right, rotating the casing now to access the drain port. There's significant silt packed in here that we need to clear. By rapidly heating the outer component, thermal expansion breaks the corrosion weld, allowing us to safely extract the plug.
We use a 40 kHz cycle to safely dislodge the heavy marine scale without damaging the underlying metal components. The ultrasonic tank removes the heavy corrosion, but the specialist uses compressed air to ensure every tooth is clear before final inspection. The 3000-watt fiber laser allows us to precisely remove the corrosion layer by layer without damaging the underlying structure. Beginning the full circular optical scan, reviewing the generated surface mesh data, dimensional accuracy confirmed, exporting the CAD file now. We're printing the replacement collar now. The UV laser cures the resin layer by layer, giving us the precision needed for these vintage aircraft components. After the chemical bath, we apply a protective oil to the brass contacts before checking the alignment on the casing base. The alignment tool confirms the spring mechanism trips cleanly. Now checking the pressure system. The gauge reads stable at 500 psi.